So this is a review of setting up metric prefix conversion factors. This is going to be in the lab report on measurements. So let's take a look down here where you're going to find this on the first page. Perform the conversions indicated, and you can see there's some metric prefixes, such as convert the measured rectangle length to nm. So n is a metric prefix. So this is the process we looked at in lecture, where you first identify the metric prefix and then write the power of 10 it's equivalent to. So this is n, which is nano, 10 to the minus 9. So you want this to be a nanometer, that's the unit associated with it, so you multiply m onto both sides. nm equals 10 to the minus 9 m, so meters is on both sides. Put a 1 in the front, and this is going to be the conversion factor you use to convert. So let's say you measured that rectangle length and it is 12.15 centimeters. Okay, so now this also has a metric prefix in there, so let's underline that. This is C. So that means you're going to need another conversion factor. So setting up a conversion factor using this C, this is C, that's centi, which is 10 to the minus 2. We want it to be a centimeter, so multiply m onto both sides. Centimeter equals 10 to the minus 2 meter. Put a 1 in the front, and that'll be your second conversion factor. So we're going to use both of these conversion factors to convert this. So let's turn to purple, let's say. We have 12.15 centimeters is the example rectangle length. And we're going to use both of these conversion factors. So that means setting up the fraction symbols. So this is fraction. And then deciding what's going where so that we can cancel units. So the goal is to cancel units. So we have centimeters here in the numerator. So down here in the denominator, I want centimeters. I'm going to choose this 1 cm because that out of all four of those is the only one that has centimeters. What it's equal to, the other side of this equivalence, the conversion factor, is 10 to the minus 2 meters. And that's what goes on the top of the fraction. Remember, any equality can be set up as a fraction, top and bottom. So then let's use this to cancel out. So centimeters and centimeters will cancel out, and that means the units that I have next up on deck to cancel out are meters. So I use this, so I'm going to use this one, and I need meters. So this only option here is 10 to the minus 9 meters, goes on the bottom. So this on the top of this fraction is the other side of the equality, which will be 1 nanometer. Okay, so what cancels out now is going to be meters and meters, and the units that remain are this nanometers. That's good because that's what I was trying to solve for. Once the units check out, you can write an equal sign, leave a bunch of space for the number, and then you want to write the units nanometers out there. So that's what I was trying to solve for. So now you can go to the calculator, but I actually don't need to calculate most of these because I have this number, 12.15, I'll switch to blue actually, 12.15, then I'm going to carry over to here, 12.15, and then times, I'm going to compress, this is 10 to the minus 2, that's on the top of the fraction, 10 to the minus 2. This is a 1 and a 1, don't need those, but 10 to the minus 9 is going to go on the bottom of the fraction, 10 to the minus 9. And so now I have this powers of 10 with the exponents. When you're dividing exponents, you subtract those exponents, those small number values. So writing this out is going to be minus 2 minus 9. Okay, so that's the minus 2 and the minus 9, and I subtracted them here. Now, when you have two negatives, this makes this positive and positive. So this is going to be minus 2 plus 9, or 7. So that leads to not 7, but 10 to the 7, because I was dealing with the exponents. So now, going back to blue, the answer is the 12.15 times 10 to the 7 and nanometers. Okay, not done yet because I want to put this answer into scientific notation. So that means more than 1 but less than 10. So move this decimal over. So this becomes 1.215. Keep all those 4 sig figs because our original value had 4 sig figs. So 4 sig figs in the original value, 4 sig figs in the answer. Okay, and then this is going to be 12 went to 1.2, so this coefficient part, this decimal part, got smaller, so the exponent needs to get bigger from 7, 1 up to 8, and this is going to be nanometers.